Solve the following system of equations graphically. Recall that a linear equation involving two variables corresponds to a straight line on a graph. Each point x, y on the line satisfies that equation. A system of linear equations contains more than one linear equation. Also then, corresponds to more than one line on the graph. The solution to a system of equation is the point, or sometimes points, that satisfies all equations. This is the point of intersection. In this case, the point 2, 1. Note that linear equations can have more than two variables. However, to solve a system of equations, there must be at least as many equations as there are variables. For two variables, there must be two equations. For three variables, there must be three equations. The equations here are both given in standard form. ax plus by equals c. For the first equation, 2x minus 3y equals 6, we'll subtract 6 from both sides to express the equation in general form. This results in 2x minus 3y minus 6 equals 0. Recall that general form is ax plus by plus c equals 0. For this equation then, a equals 2, b equals negative 3, and c equals negative 6. Also recall that for general form, the x-intercept is equal to negative c over a, or in this case, negative 6 over 2, which simplifies to 3 as the x-intercept. We can then plot this point at 3, 0. The y-intercept for general form is equal to negative c over b. In this case, negative 6 over negative 3. This is equal to negative 2, corresponding to the point 0, negative 2. Then draw a line through these points, remembering arrows on both ends. For the second equation, this time as a review of different methods to graph a linear equation, I'll convert to slope-intercept form. Subtracting x from both sides gives y equals negative x minus 7. Recall slope-intercept form, y equals mx plus b. Here, m equals negative 1, and b equals negative 7. The y-intercept, which is corresponding to the b, is equal to negative 7. This corresponds then to the point 0, negative 7. The slope equals m, which is equal to negative 1. This means that from the y-intercept, we move up 1 and left 1, giving the point negative 1, 6. Connecting these points with arrows on both ends gives the line corresponding to the second equation. The intersection point, which gives the solution to the system, is at negative 3, negative 4.